In our previous video, we distinguished between categorical and numerical data. Furthermore, we saw that numerical data can be discrete and continuous. It's time to move on to the other classification, levels of measurement. These can be split into two groups, qualitative and quantitative data. They are very intuitive, so don't worry. Qualitative data can be nominal or ordinal. Nominal variables are like the categories we talked about just now, Mercedes, BMW, or Audi, or like the four seasons, winter, spring, summer, and autumn. They aren't numbers and cannot be ordered. Ordinal data, on the other hand, consists of groups and categories which follow a strict order. Imagine you have been asked to rate your lunch, and the options are disgusting, unappetizing, neutral, tasty, and delicious. Although we have words and not numbers, it is obvious that these preferences are ordered from negative to positive. Thus, the level of measurement is qualitative, ordinal. Okay, so what about quantitative variables? Well, as you may have guessed by now, they are also split into two groups, interval and ratio. Intervals and ratios are both represented by numbers but have one major difference. Ratios have a true zero and intervals don't. Most things we observe in the real world are ratios. Their name comes from the fact that they can represent ratios of things. For instance, if I have 2 apples and you have 6 apples, you would have 3 times as many as I do. How did I find that out? Well, the ratio of 6 and 2 is 3. Other examples are number of objects in general, distance, and time. All right, intervals are not as common. Temperature is the most common example of an interval variable. Remember, it cannot represent a ratio of things and doesn't have a true zero. Let me explain. Usually, temperature is expressed in Celsius or Fahrenheit. They are both interval variables. Say today is 5 degrees Celsius or 41 degrees Fahrenheit, and yesterday was 10 degrees Celsius or 50 degrees Fahrenheit. In terms of Celsius, it seems today is twice colder, but in terms of Fahrenheit, not really. The issue comes from the fact that 0 degrees Celsius and 0 degrees Fahrenheit are not true zeros. These scales were artificially created by humans for convenience. Now, there is another scale called Kelvin, which has a true zero. 0 degrees Kelvin is the temperature at which atoms stop moving, and nothing can be colder than 0 degrees Kelvin. This equals minus 273.15 degrees Celsius, or minus 459.67 degrees Fahrenheit. Variables shown in kelvins are ratios, as we have a true zero, and we can make the claim that one temperature is 2 times more than another. Celsius and Fahrenheit have no true zero and are intervals. Finally, numbers like 2, 3, 10, 10.5, I, etc. can be both interval or ratio, but you have to be careful with the types you are operating in. All right, we've quickly gone through the types of data and the measurement levels. Stick around to see the types of graphs that are used on a daily basis.